All right. Good morning or good afternoon, class. Hope you're doing all right here. What I'm going to do is I'm going to actually repeat lesson in 5.2 since we didn't finish it. So scroll to the video or rewatch it if you'd like, or scroll to the part of the video that you think we left off. So anyway, here we go. Lesson 5.2 is on properties of exponents. So the keywords that you want to know here is knowing what the base is and what the exponent is. So those are the two terms that we want to talk about. So what happens is we'll have something to the extent of x to the n power. Sometimes I like to, instead of using that, use b to the e power. The number here we call the base. Hence why I like to sometimes use the word b. The exponent is written as a superscript. And what you remember from probably junior high is probably when the first time you saw it is what an exponent means is whatever the base is, you're multiplying that value by itself that many times. So in this case, x to the fifth would be saying multiply x by itself 5 times. Even if I had something like this, a squared b cubed, what that would mean is I'm multiplying a by itself 2 times, followed by multiplying b by itself 3 times. Now what's interesting is we'll start to lead to problems where we want to start to multiply where the bases are the same. So for example, we might start to take a look at a problem like this. X squared times x to the third power. How can we simplify that? Well, if we think about what x squared is, it's just simply x times x. What x to the third power is x times x times x. What's happening is we're multiplying now all these x's together. So now we have 1, 2, 3, 4, 5 of them. So we have x to the fifth. What hopefully we notice is that when we actually start to do stuff like that, another and faster way that we can actually get to it is by simply adding the exponents. So this leads to this rule right here, the product property. So a to the m power times a to the n power is equal to a to the m plus n power. So you add exponents. Okay? And this is the most important thing. You add the exponents. The other thing is the bases must be the same. Okay? So let's take a look at a couple examples here that are in the notes. So like on this first one, x to the fourth times x to the fifth is simply x to the ninth. I'm going to add a few more examples here because I think it's always great to see when you got more. So like if I have y squared times y to the fifth, that would just be, add them up, y to the seventh. What if I have like x squared y to the fifth times x to the third y to the seventh? So if I have something like that, you just do the same bases and add those exponents. So I group the x's together. So that would be 2 plus 3, which is x to the fifth. Group the y's together, 5 plus 7, y to the 12th. Now, the next question with it becomes, well, what if I have a number in front? Okay? Well, if you just have numbers in front, it's just like multiplying. So it's like saying 3 times x squared times 5 times x to the 6th. So multiply the numbers together. 3 times 5 is 15. Now deal with the x's, both same base, x squared, x to the 6th, x to the 8th. So that takes care of the product property. What if now you're dealing with fractions and you're doing division, okay? What if you have a problem like this? Okay. So what if I had x squared over x to the fifth? Okay. Well, if we think about it the long way, x squared is like x times x, while x to the 5th is times itself 5 times. Well, we know that x divided by x is like saying 1. So they cross out, they leave a 1. Technically, anything times 1 is itself. So a lot of times we just like to say they cross out. It's always good to have the 1 there so that you don't forget if everything crosses out to put the 1 back there. So here, another set of x's cross out. So if I look here, I have 1 in the top, then I have x times x times x, x to the 3rd. So if I look at this, I have 2 minus 5. If you look at this rule, you can actually subtract the exponents, but when I do, okay, I would have x to the negative 3rd power. One of the rules we'll explore a little bit later is that if you have a negative exponent, to make it positive, it goes in the denominator. So a lot of times when I do actually this with the quotient property, which means to subtract the exponents, I still subtract, but my answer goes where the bigger exponent is located, okay? So I can avoid the negative exponents. So just to demonstrate on these next 4 examples, let's take a look at these here. So on the first one, x to the 8th over x squared, I have 8 minus 2 is 6. Since the bigger one's in the top, it's going to be in the top, x to the 6th. It's that easy. On the next one, I compare my x's. Notice how I have 8 in the bottom, 3 in the top. So that's going to, 8 minus 3 is 5. But since 8's in the bottom, the x also goes in the bottom, so it's x to the 5th. When I do the y's, y to the 6th over y to the 2nd, 6 minus 2 is 4. 6 was bigger, so the y to the 4th is actually in the top part of the fraction. Sweet. All right, let's take a look at the next one. Ooh, how do we do numbers? Well, if you look at 15 and 10, what you can do is ask yourself, what number actually goes into it? Well, 5 goes into both of them. 5 goes into 15 3 times, goes into 10 2 times. If you really struggle with that, here's a little calculator trick. Type in 15 divided by 10. Go ahead and hit enter. It's going to give you a decimal. Hit the math key and enter, and it'll change it to a fraction for you. Okay? So we do want to keep things as fractions, not decimals. Going to finish up with the x's. X to the 7th over x to the 4th. 7 minus 4 is 3. It's bigger in the top, so x to the 3rd. All right, do the same thing with this one. 2 divided by 16. As you can see, a decimal, math, fraction. I get 1 over 8. So 1 over 8. So now I'm going to do look at all these, x. 5 in the top, if there is no number, again, it's always a 1. 5 minus 1 is 4. It's in the top, so x to the 4th. Do the y's. 12 in the bottom, 9 in the top. So 12 minus 9 is 3. Since 12 was the bigger number in the bottom, the y's go in the bottom. Same thing with the z's. Since 7 is bigger in the bottom, 7 minus 1 is 6. So z to the 6th. All right, that takes care of the first page. Let's flip to the second page and talk about 2 more rules. What if you have an exponent being raised to an exponent? This is called the power of the power property. How does this actually work? So if we think about this, if I have something like x squared and I'm raising it to the 3rd power, what it means is x squared times x squared times x squared. Well, now if I break this down even more, x squared is like saying x times x, and I'm doing that 3 times. So now if I count up all my x's, I have simply x to the 6th. Would there be a faster way for us to get that 6? Absolutely. We can multiply. So when a power is inside raised to a power on the outside, so like a lot of times we'll say a power to a power, you multiply the powers together. Powers is another term for exponent. You multiply those exponents together. Now the last rule that's kind of cool here is anything to the 0 power equals 1. okay? Now you might be thinking, why in the world is that the case? Why is anything, to the 0 power equal to 1? Here's the quick way of showing it to you. If I think about 2 to the 3rd power, it's like saying 2 times 2 times 2. Are you okay if I say multiply by 1? Just at the end. 2 to the 2nd is 2 times 2, and I still have this 1. 2 to the 1st is 2 times 1. So the question becomes, well, what should 2 to the 0 be? Well, follow the pattern. Notice how as I'm going down by one exponent, I'm losing a 2. I had 3 of them. 2 of them. 1 I don't have anymore, but the 1 is still there. I can do the same thing, not just for 2, but this could be 5, and I have 1 less 5. This could be x. I would have 1 less x. So anything to the 0 power is 1. You don't believe me? Here, I'll just type in a whole bunch of numbers. I'll raise it to the 0 power. Look at what happens. You get 1. All right. So let's do these. All right, power to a power. So on the first one, 4 times 7, 28. So x to the 28. Now, you got a number. You also have to take that number to the power. So it's not 2 times 4. Don't make that mistake. It's actually 2 to the 4th power, and then you're going x to the 12th. So then you got to simplify 2 to the 4th power. So if you need to, use your calculator. 2 to the 4th power is 16. So 16x to the 12th. All right, the next one. We're now raising a bunch to the power. So 2 to the 5th times x. 2 times 5 is 10. 3 times 5 is 15. 2 to the 5th power. If I do that on my calculator real quick here, 2 to the 5th power. Whoops, helps if it takes the exponent piece. Should be 32. So 32, x to the 10th, y to the 15th. All right, on the last one, we got a bunch of them that we're going to do together. This is like putting everything together. So let's do this part first. So if I do this part first, sorry, having a little technical difficulty here. Let me see if I can get things to work better. All right, can you hear me at all? Hopefully you can still hear me. So as I do this one, 5 squared, 25, x squared, 4 to the 3rd power. So on my calculator, I can go 4 raised to the 3rd power. Then I get 64. X to the 2 times 3 is 6. 3 times 3 is 9. Do the last one. Anything to the 0 power is 1. So, sorry, this one was that part, and this one is the 1. So now I got to multiply. 25 times 64 is 1600. So that takes care of the numbers. X squared times x to the 6th. Now this is where we add exponents. The only y's I have is y to the 9th. Anything times 1 is 1. And I have my answer. All right, so that ends our video for the notes.